Okay. So yesterday we started talking about phase changes, and phase is just a fancy science word for state of matter. So when we talk about our phases of matter, we're just talking about our states of matter. The three that we talk about are what? What are our three states of matter? Liquid, gas, and solid. Yeah. So we've got three states of matter, and that's what we're going to look at today, because yesterday during the lab, there was a little chart, like you could look at the graph, and it was like the lines kind of did something. So what I'm going to show you today is what we call a heating curve. And this is the way we can tell what happens when we're going from, like, if we take a piece of ice and we set it out on the countertop, basically if we wait for, a couple hours, eventually not only is it going to melt, but eventually the water on the table is going to evaporate. Well, we actually have graphs to show what happens with both the energy and the temperature during that situation, where it's going from one state of matter to another. So that's what we're going to talk about today. All right. So here's my suggestion, is that you do your notes instead of like the paper. Let's see if I can get it all the way up. Instead of using your paper up and down like this, my suggestion is that you turn your paper sideways, because that's how I'm going to do my notes. And so it'll probably work out a little bit better for you if it looks somewhat similar to mine. And these notes aren't going to take super long. There's a lot of information, but it's a lot simpler than it sounds. Okay. So what I'm going to do is right here at the top, I'm going to do it kind of little. I'm going to call these notes heating curves. Okay. Heating curves. So if you want to label your notes, you can do that. Okay. Heating curves. So we're gonna just go into this, what teachers call cold, which means I'm not gonna show you a picture of what a heating curve looks like yet. Although, if you took 8th grade physical science, you've seen these before, 100%. And so we are going to get right along with our stuff. Let me make sure I got my life together here. Okay. So the very first thing that you're gonna do is we're going to come down a little bit. So this is my whole paper. Here's the top. Here's the bottom down here. Okay. What we're going to do is we're going to come like right here. And we're just going to draw little axes like that. Okay. Just like that. Mello, you need paper? Okay. Does anyone else need paper? You have paper? All right. So far so good. Not so bad, right? So the first thing we're going to do is we're going to label our sides, our axes. Okay. So here's how we're going to label them. We are going to label them as the bottom one is heat energy. Okay, heat energy. And I always like to do an arrow like that. Okay. And then this side over here is going to be temperature. And I'm going to draw an arrow that goes up. Okay. Which you guys already know how graphs work. So you know that if we're traveling this way, that our value is going to increase. Okay, so now that we've done this, before you start drawing lines, I'm going to draw our little lines that go here. It says heating curve, but it's actually not a curve at all. It's just straight lines, which is nice. But this is very specific. So don't just be drawing stuff. Wait like 2 seconds for me to finish drawing it, and then I'll tell you, like, go ahead. So let me show you. Just like that. Oh, Okay, so now what we're gonna do a couple of different things. I'm gonna put some letters and some arrows and stuff here. So we're basically going to label using like letters, and then we're gonna make ourselves a little key down here and put some stuff over to the side, and that's gonna be our notes. So make sure that you draw this carefully, that you're paying attention to what you're doing, because if you get the parts wrong, then it's gonna be very difficult to do the practice. Okay, because this is going to be very helpful, because almost every single heating curve is set up the exact same way. Okay, so here's what I'm going to do. I'm going to put an A with an arrow going up like that. And then I'm going to do a B right here with an arrow going up. And then C. That's D right there with an arrow down. That's E. That's F. And then so just make sure that when you label these sides right here with the 0 and the 100, the 0 should be all the way down here at the bottom. The 100 needs to be across from this straight line where H and J are. So you can just go like over here, and as long as it's somewhere around there. And then I'm going to label H, I, J. This one's going to be K. No, that's blue, so sometimes it's kind of hard to see. And this one right here will be L. And if you want to put like periods after them so that they look like actual labels, totally fine. And we're done with our picture. So we're going to start on our key in just a second. Oh, wait a second. No. Okay, one second. Y'all keep working. Okay. Okay, awesome. Okay, so I'm going to start on our labels. All right, so here's how I'm going to do it. All of our labels are going to be kind of down here on my paper, which means if you're doing it like me, that's probably where you should put your stuff. So we're going to have like three or four categories. So we can organize our thoughts, right? So the first thing we're going to do is we're going to put states of matter. Yeah. Okay, states of matter. And under this category, what we are going to do is we're going to put A, B, and C. Okay, A, B, and C. So A, which is right there, these are solids. B, liquids, and C is going to be gases. By the way, the word gases only has one S. Okay. So really quick, let me show you on our little chart now that you guys, okay. So it says wherever A is, that's a solid. Well, A is right here. So this line right here, so if we're talking about water, right? This line is showing us what happens when we either increase or decrease heat energy in the form of temperature. So if we increase heat energy, the temperature is going to go up. So what happens here is that this is the substance. And what's happening is we're starting at 0 degrees and we are working our way up. I made a mistake. You need to fix something. Hold on. Y'all need to fix something. Everybody who's making their notes, you need to change something. The 0 degrees goes right here. Okay. Sorry. So the 0 degrees should go right there, across from the first flat line. I'm so sorry. And then that's K. So I'm just gonna. Okay, did everyone fix that? I'm sorry. Too many tabs open in my brain today. All right, so that's our states of matter. A is right here. That means that if this is water, if I say like, oh, what state of matter is position A? This is gonna be a solid right here. Solid water is called ice, so that's gonna be ice. Now, B is a liquid, so that's right here. So that means that this is just regular liquid water from here all the way to here. These slanted lines. We're not talking about the flat lines yet. And then C is a gas. So that's up here, okay? So those are our states of matter. Solids, liquids, gases on the curve. By the way, this is almost exactly the same order they go in on every single curve. Every single one. Sometimes the curve will be backwards, but it works the same way. So as long as you have these notes, that's why we're doing them, you should be just fine. You should be able to read all the heating curves you want. All right, our next category is going to be phase changes. Okay, phase changes. That's our next category. Okay, so a different color. Blue. Let's do pink. Why not? Can we see this? No, you cannot. But you can't see this one. All right, so here's the first for our phase changes. We're going to do G. Then H. Then I. Then J. Okay. So let me ask you guys a question. Well, I'll give you like 10 more seconds to get that done. And then I'm going to ask you a question. Okay, I want you to think about this. Think about it. We just said that A is a solid and B is a liquid. So look at our graph real quick, or look at my graph. Here's A and here's B. A is a solid, B is a liquid. So if this is water, solid water is called ice. B is a liquid, that means that this is just regular liquid water. So if you start with ice and you end up with regular liquid water, what process happened? What did the ice do? It melted. So phase change where G is, this is melting. Okay, melting. And the same thing. Okay, so here's B. This is a solid and C is a gas. So if we have, or it's not solid, this is a liquid, sorry. So if we have liquid water and then it turns into water vapor, what happened? So think about this, the temperature is going up. So if you have regular liquid water and you put it in a pan on your stove and you turn up the heat, it's gonna evaporate. Is that what you said? What happens before it evaporates? It sizzles, which the word for that starts with a B, boiling. So H on top, to go from a liquid to a gas, this is going to be boiling. You're not wrong, by the way, Anaya. You're not wrong at all, because evaporation does happen somewhere in here. Okay. Now, if you notice, I put arrows, right? Because we can move up the graph this way, or we can move down the graph this way. So here's I right here. And what's happening is we're going from this line, which is liquids, to this line, which is solid. So if you have liquid water and then it turns into solid water, what happened? It froze. So I is freezing. Okay. And then J, if we're going from a gas to liquid water, think about the water cycle. Once the water goes up into the atmosphere, into the clouds, how does it come back down to the earth? What does it do? Y'all remember? What? It rains, that's what happens. But where does the water for rain come from? From the clouds. And what happens in the clouds? Do y'all remember? I know this is like way old school stuff. Do you remember what happens? If you go on a window, eventually the window is going to get foggy, and then eventually you're going to see little water droplets. When a gas turns back into liquid water, we call that condensation. It condenses. So you're taking this gas that's kind of out here, the molecules are all moving around, and then they slow down just a little bit. And when they slow down, that condenses, and then you get liquid water again. So, or for example, if you have a soda or something that you get out of the vending machine and it's super hot outside and you take it outside, what's going to happen to the outside? It's going to get warm. And when it gets warm, you're going to have liquid all over the outside, water all over the outside of the can or the bottle. And what that is that it's all of the water vapor cooling off and turning back into a liquid. So this process right here for J, if we're moving this way, if we're going from a gas to a solid or to a liquid, gas to a liquid, this is condensation. All right, our next category is going to be, I'm going to call it something kind of weird. It's not weird, but you'll see. Okay, so the next category is going to be, I'm going to abbreviate temperature because y'all know what temp means at this point. So temperature points is what I'm going to call this. Okay, temperature points. And the ones that are going to go in this category, the ones that go in this category are K and L. Those are the only two. Okay, so let me show you on this graph really quickly. Here's K. And remember, this is the one we fixed. So make sure that you have that one fixed on your paper. Okay. So here's K and here's L. So this guy is right across from this line right here. Well, guys, guess what? We've already labeled G. G is melting. Okay, so this point right here, 0 degrees. This is a temperature that has a name. Because something happens at that temperature. There's two things that happen. Do what? You say 35? 32. But 0 degrees Celsius, yes. And 32 degrees Fahrenheit are the same temperature. So here's what's happening at K, at 0 degrees Celsius. This is a temperature. Here's two things that are happening. If we are going up, okay, up the graph from A to B, this process right here is melting. So this guy right here, what K is, the 0 degrees, this is your melting. And we're going to put a slash. Okay, so because if we're moving this way, we're getting warmer. This is going to be your melting point. And then if we're getting colder, if we're going from liquid water down to solid water, this point right here, 0 degrees. So this is the melting / freezing point. Okay, melting / freezing point. And L, this is your boiling / condensation point. Okay. There is one other thing you need to know. And if you have room, you can write it down underneath here. That's where I'm going to put mine. But if you don't have room down here, you can put it up here or over to the side, wherever you've got room. So. So temperature points, K and L, we've got our melting, freezing point, boiling, condensation point. The next thing is, and this is the last like labels that we're doing, and then we're writing a couple of little notes that are really going to help you with your practice today. Okay, so we're going to call it temperature changes. And we're going to write one thing for this little part. For temperature changes down here. I'm going to put I and J. Only during 7th period. Oh, and 6th period, but yeah, I'll make sure no one touches it. All right, I and J. Here's what's happening. So I and J right here, I and J are kind of in the same place as G and H. Here's the thing, G and H tell us about what's happening with the phase change. What is it changing into? What's happening? What process? I and J, the reason I put these on here is because this question gets asked all the time on tests, quizzes, worksheets, et cetera, et cetera, et cetera, et cetera, et cetera. All the things. Anything having to do with heating curves, you can expect this question. What they love to say is, during a phase change, is the temperature changing? So here's what we're going to put. I and J. No temperature change. That's it. No temperature change. We are almost done with notes. Then you got some practice. Okay. So I'm assuming everyone's got these parts and that we can move on. We're going to put a couple of little like notes off to the side over here. Won't be too much, so no worries there. So here are a couple little notes. I'm going to bring this down just a little bit, but I'm going to do this to the side of the graph. Okay. We're going to write a couple little things here and then we're done with our notes. Yes. Okay, so I can't get it to. Let's see. All right, Garrison, if you're going to take a picture, you need to take it now. You good? Okay. Thank you. All right, so we are up here in our little set next to the graph. So here's the first thing we're gonna put. Okay, here's our little notes about the heating curve. When heat energy, make sure you write the word energy. When heat energy increases, or if you are trying not to write the word increases a bunch, you can go with an arrow up, okay? The kinetic energy, do y'all remember what kinetic energy is? Kinetic energy, do y'all remember what kinetic energy is? It's been a while. Kinetic energy is movement. Any sort of movement, okay? So when heat energy is increased, the kinetic energy or the movement increases. And kinetic energy, I'm going to add one little thing down here. Kinetic energy of particles, sorry. Okay. So I want you to think about it like this. Okay. If you are stuck inside a room and they turn the temperature up really, really high, it's going to become really uncomfortable for you. You're probably going to want to find a way out. So what happens is you'll start to move a little bit faster, right? Trying to figure out how you can get up out of the, or better example, you're locked out of your house in the middle of the summer. You start really trying to get to work to find a way into your house, the hotter it gets, the longer you're outside. So what happens here is when you're increasing heat energy, then the kinetic energy, which is just movement, the motion is going to increase. So that means if we are, let me show you the graph really quick. Here's our heat energy down here on this axis. That means that as we go this way on the graph, the heat energy is going to increase. So solids do not have as much movement as liquids because the heat energy has increased. And when the heat energy increases, the kinetic energy, aka the movement, increases as well. And then gases have a lot of movement, more movement than liquids. Okay. So, and I'll show you something about that in just a second whenever we get done with our notes. Okay. So there are two terms you need to know and just be familiar with. The first one is called heat of fusion. Okay. Heat of fusion. And here's what it is. The amount of heat, energy, or the amount of heat needed to turn a solid into a liquid. That's what heat of fusion is. I'm going to go ahead and write the third one, and then we'll talk about that. And I am actually going to add one more thing, but it's really important. We've already written it, but we're going to write it again. I'm actually going to write it in all caps. The temperature does not change during a phase change. I'm glad you did. How's it going? Are you surviving? Are you surviving? Yeah.
I mean, I passed my own
Huh?
so I can go home.
Yeah.
You gotta eat fruits. Now you can't go home.
Is that what you said? Now you can't go home?
I mean, I can't go wrong. I passed it.
You can't go wrong. That's true. That's true. That's true. Okay, so make sure you get 2, 3, and 4 written down.
Oh, because y'all tell me stuff. So what do we do? What things actually sorry. No, it's not that great. Honestly.
Almost there. And then we're going to talk about it.
So,
Restroom.
She just be leaving fast. Like, I don't know. I could just get up, wake it up, and yeah.
I do that sometimes. Sometimes it's awkward to announce the whole class that you're going to the bathroom.
I don't even know if that's how you pronounce my first name, honestly.
Minerva. Yeah. I only know that because of Harry Potter. Okay, this is so important. The temperature does not change during a phase change. So if you let ice melt on the countertop, while it's melting, there is no change in temperature. That is a question that will be asked 100% on your test. No questions asked. Okay, does the temperature change during a phase change? No, it does not. I know it seems like it might, but it's not going to. Okay, if you are finished with your notes, I want you to go ahead and pull up, and for you guys out here, I will actually print them out for you. See, I don't have to worry about that. Zoom, when you're finished writing your notes, please go ahead and open up the worksheet that is linked on Google Classroom. And I'll print it out for you guys. So I want to take you through one of them, or one set of questions, so you guys can practice before you finish the rest of the worksheet yourself. Okay. So
My food. Yeah, I know. Yes. The rest of it. We kind of like to do it. I'm excited about that.
Sorry, Sam, give me 1 second. Give me a second. I promise. The printer's just being slow. I'm sure you can see me.
And this girl actually sat down and we did a whole bunch of changes. We changed everything because that was so boring. It was so boring. Ooh.
You gonna say hello to Zoom?
What do you think about me? Oh.
All right, so let's take a look at this worksheet. Zoom, y'all had plenty of time to get it out. So this is what it looks like. We're gonna walk through this together for number 1. Okay. So I want you to notice the similarities between your notes and what's going on here. They look the exact same. The lines aren't all the same length like ours are, but all the same parts are there. So the first question says, what phase or phases, that means plural, are present during segment 1? Well, here's segment 1 right here, this little guy right here. So if you're like, I don't know, use your notes. That's why we just did them. So that's the same segment that it has right there. Okay. So what it says, what phase or phases? So what state of matter? So what state of matter is this right here? This first diagonal line. Solids. Absolutely. Okay. Okay, solids.
No change. There's no change.
Mm-hmm.
Oh, what is this again? This is chemistry.
Yeah.
Barely paid attention last year. I still know this.
Girl. Jalen too.
Literally.
And I would know. All right, so look at B. We actually put something on our notes to help you answer these questions. For 1B, it says, what is happening to the energy being absorbed from the heat source? It says, put your answer in terms of potential and or kinetic energy. Let me direct your attention to number 1 from the side over here. Okay. When heat energy increases, the kinetic energy, which is the movement, increases as well. So the kinetic energy of the particles. Okay. So here, when it says, what is happening to the energy being absorbed from the heat source? So look here, guys, y'all know how to read a graph, I hope. If you don't, you need to talk to me or you need to talk to a math teacher, really, okay? So this line right here, let me use a marker, okay, is moving up. That means that as time goes on, time is going this way, that the temperature, if we ignore time for a moment, it's starting down here below 0, and making its way up. So if it's moving up, that means the temperature is changing. That means our heat energy is going to be increasing. So what happens to the energy being absorbed? The energy absorbed the energy that's absorbed turns into kinetic energy, which remember is just energy of motion. Anytime you move, blink, breathe, move your arm, move your leg, move your head, anything like that, that's kinetic energy. So the energy that's absorbed turns into kinetic energy. We're going to be real sciencey. We're going to be real 10th graders, almost 11th graders, or 11th graders, almost 12th graders, or 12th graders, almost graduates, depending on where you are in your life. Okay. The energy that's absorbed turns into kinetic energy, making the particles move faster. That's what happens. Anytime that the energy is going up, the temperature is going up, the energy is going to go up. So what's happening to the energy? It's being turned into kinetic energy, which makes the particles move faster. This sounds like a really great test question. Yeah. Uh-huh. Okay, so it says, part C, last one that I'm going to do with you. And then, we'll see about homework. I'll decide in a minute. So it says, what phase change, if any, is taking place? So don't guess about this. The reason I put these things down in categories, so if it says what state of matter or what phase, you can look in this category. If it says, is there a phase change happening? You can look in this category. What is the melting or boiling point, or what's the condensation or freezing point? Is the temperature changing during? No. Okay, so y'all see what I did for you there. So what phase change, if any, is taking place? Here are our phase changes from our notes, G, H, I, and J. G, H, I, J. Those are the phase changes on these flat lines. So if we're talking about this line right here, is there a phase change happening? No. The phase changes happen on the flat lines. So for C, what phase change, if any, is taking place? No phase change. No phase change. All right, here's what I want you to do for the last 6 minutes of class. I want you to at least do number 2. We will finish the rest tomorrow, but you need to finish number 2.